Hey guys, and welcome to our animated walkthrough of one of LeetCode's more interesting challenges, Problem 238, Product of Array Except Self. This problem is not just about finding a solution, it's about discovering an efficient way to manipulate arrays. It tests our ability to think algorithmically and optimize our approach. Today we will unravel this problem starting with a clear understanding of what it asks us to do. The problem states, given an integer array nums, return an array answer such that answer at index I is equal to the product of all the elements of nums except nums at index I. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. We must write an algorithm that runs an O of n time without using the division operation. To get a better idea of what the question is asking, let's take a look at our first example given by LeetCode. Suppose nums is an array like 1, 2, 3, 4. Our goal is to transform nums into a new array where each element is a product of all other elements. But how do we achieve this transformation? The simplest and most straightforward approach involves iterating over each element in nums, and for each one, calculating the product of all other elements. While this method works, it's not very efficient, especially for larger arrays. Each element's product requires iterating over the entire array again, leading to a time complexity of big O of n squared. This approach, although simple, doesn't meet our time complexity requirement and can be quite slow for larger inputs. Having seen the limitations of the naive approach, let's explore a more optimized solution with another example. In this method, we will start by initializing an additional array with ones. First, we calculate the left-hand products. Starting from the left, we progressively multiply the elements of nums and store the cumulative product in our left array. In essence, each element of the left-hand product array represents the total product of all numbers to the left of the current index in nums. It's like having a snapshot of all the multiplicative contributions from the left side up to that point. Having established our left-hand product array, we will now introduce its counterpart, the right-hand product array. This array mirrors the concept of the left-hand product array, but with a focus on the elements to the right. Again, we are walking through the nums array, but this time we start from the rightmost element and move leftward. As we proceed, we calculate the cumulative product of all elements we encounter along the way. Each position in the right-hand product array therefore holds the combined product of all the numbers to the right of that index in nums. It's a way to capture the multiplicative impact of elements on the right side of each index. With both the left and right-hand product arrays at our disposal, we're now poised to find the solution. The final step is to combine these two arrays to determine our answer array. For each index I in our answer array, the value is obtained by multiplying the ith element in the left-hand product array with the ith element in the right-hand product array. This clever technique allows us to calculate the desired product for each index without using division and with an optimal time complexity. Now that we understand the logic behind our optimized solution, let's dive into the actual Python implementation. This code elegantly translates our approach into an efficient algorithm. We begin by initializing three arrays, product left, product right, and result, each of the same length as our input array nums. The first two are filled with ones while result is initialized with zeros. The first loop focuses on calculating the left-hand products. Starting from the second element in the left product, we multiply the previous element in nums with the previous element in left product. This loop effectively builds our left product array where each element represents the cumulative product of all elements to the left in nums. Next, we compute the right-hand products. This loop runs in reverse starting from the second to last index. For each iteration, we multiply the next element in nums with the next element in right product, populating our right product array. With both the product left and product right arrays ready, we now loop through the result array. Here we multiply the corresponding elements from product left and product right for each index. This operation gives us the final product of all elements except the current one, as required by the problem. Anyways, that's an animated solution for product of array except self. If you found it helpful, make sure to like and subscribe. Thanks for watching.